Now, welcome to the developer meeting on Sunday, the 9th of April. And the first demo is from John. Yeah, go ahead, John, without further ado.
So you have to tell me if you can.
Yes, we can see
my. Okay. So I presented before on the Sky 360 GUI video stream feature. This is I mean it's our now our common status on the roadmap with our team and the people supporting and helping in that. And so in the current week we have set up the environment, prepared for testability of the video stream plugin, and so this was already planned and brought up 2 weeks ago. We did it. Now we have, in addition to the simple track, our development happens on 2 containers. For one, the simple tracker ROS2 WS. On the other hand, a new container, Guy OpenMCT container, which was based on a Docker file that Dan created this week, and Fabio enhanced it and integrated it. So now you can go to the repository, pull the GUI OpenMCT container, and work on it like you work on the simple tracker one. Yeah, and thanks to Mike, who already a week ago added a compressed image topic. We can use compressed images because the BGR8 codec that is used in ROS2 is not a MIME standard that the international internet organization essentially has specified. Hence, browsers don't implement it. So we went for JPEG for now, which is open for discussion, but and so we went for the video stream development and testing the environmental setup, which worked out. And we validated that the setup works by a video stream from simple tracker ROS2 WS container to OpenMCT GUI container as iframe in an OpenMCT front end. Just now, Dan created a 3JS DOM perspective of fisheye imagery. And so our goal was for the calendar week 14 to familiarize ourselves with technologies for the camera feed, video player plugin, and have set up the environment on our side for development and testing. And set a baseline for benchmarking against, which means we now have a video stream, and then if we do something else, we can at least visually verify if it performs better or worse in terms of compression or buffer or the like, or aspects like essentially that. And here's some simple track ROS WS source. ROS bridge runs on the simple tracker container GUI. And on the OpenMCT side on Node.js, on the same Node.js, so also there's the video stream front end loaded from or hosted at, and the video stream front is integrated into as an iframe into OpenMCT. And this is just the video that I already posted on in the GUI channel. Here you can see essentially the OpenMCT with the stream. Yeah. So I will also live demo that. So I will stop here. And now the next one is the fisheye 3JS DOM protection by Dan, because he has experience with 3JS. Maybe Dan can just say something about it right now.
Yeah, this is just kind of putting the video feed through, and if you can imagine the fisheye image projected onto a kind of a dome in 3D, and you're kind of standing at the center of that, kind of looking around, and you can use your mouse to kind of control that and kind of visualize it. You could also imagine other elements being put into that scene, such as a plane's, crack, or stars, or other bits of data. But that's just that to kind of show you what that would look like.
So that means that whatever you project on the 2D map will then by 3JS be mapped on a spherical map?
Yeah, and that's actually without any distortion removal. So I was really surprised how nicely it looked, or how nice it looked without any kind of tweaking of that dome. So we can even probably get it to look nicer by manipulating the exact kind of curvature. And you could do a live feed potentially just by mapping that feed onto a dome to visualize it.
Cool. So it would give us a new option in the playback to see it, let's say, 3D dome view versus a 2D view.
Yeah.
Okay.
Yeah, and you could, yes.
What's the settings for the camera? Like the f-stop or the iris. I don't know if you have control over the iris. Well, I guess you do on that lens.
So this, I just used a pre-recorded video from the Simple Tracker repo.
Okay.
So I just took. This isn't an actual feed that I produced. This is just a video that I used.
Mm-hmm.
Looks good.
Yeah.
Yeah, basically.
Yeah.
This
So
is
that's with no.
Not live.
Yeah. Yeah. Okay. But the projection is a spherical projection, I assume, and.
It is, and that's what I was surprised at how good it looked without having to do a parabolic projection and do a manipulation of this this specific equation. So I think we could get even better to describe this specific optics.
Do you have a zoom tool on it?
Yeah, you can zoom in.
Can you There's a plane that's going right through the middle of the cloud, right there on the left-hand side. Can you zoom in on that?
So this is a video that I recorded. I can do. I could probably do a screen share and demo it.
Right there.
As well. But that's kind of what I was doing a little bit of. But I can show you a little bit later.
Okay.
Cool.
Okay, so I will continue now.
Yeah.
If that's okay. Okay, for next week, we will. I expect that we will meet again. As in, I predict this will happen. Specification of the initial architecture and the initial design for the camera feed. So we will again talk about what exactly we want to do there. Then I will divide implementation work packages between the two of us, and so far that is reasonable. I mean, this is just the plan as it stands, as I told 2 weeks ago. Plan timeline for implementation, code reviews and testing, and implement and test. Next week, the week after next week, implementation testing, review, documentation, commit stream, video stream feature, alpha version to main, and then of course the usual. Then a new development cycle would begin. So questions, feedback. Do you see any roadblocks? Are there relevant people available in calendar week 15 and 16? Should another stakeholder be involved? Oh, sorry. One thing I have to say before. I'm not sure I fully clarified it. Like, really, thank you, Mike, for this great work. Thank you, Fabio, for your great job, and Dan and everyone, Rebecca too, of course. Everyone, thank you. This was a real team effort, and yeah, that's what I want to say. Yeah, and so any questions, feedback? Do you see any roadblocks? Are the people available? And should another stakeholder be involved?
Great job.
Yeah,
John.
great job. Well done, John.
That's
excellent work.
Great. So if there's no questions for now, but you can continue, of course, ask after. I will just
I
give
do
a short demonstration. Oh, okay, yeah.
just a quick question. I wanted to be clear. Was the video stream actually comprised simply of JPEG images being
This video
rather
stream.
than an actual
Yeah,
rather
exactly.
than a video stream?
It's the but essentially the same as in the simple tracker X window. It's the same stream, which is also essentially it's also image packet. It's there. It's BGR 8 images, and now it's instead the BGR 8 images transformed into JPEG images. So yeah, it's JPEG images essentially. And but
Okay.
it doesn't differ technically, but you don't get anything better from the X window. It just does the same, just with BGR 8 instead of JPEG.
Yeah,
Okay.
So it's
All right.
yeah.
And there was
So-
one other thing that I was going to say that I forgot to mention. Something else that I was kind of playing around with on the masks. And again, apologies if I'm if this has already been either created or explored in the past. But I was looking at creating potentially an SVG that would be more kind of vector based, and created just a little mock-up demo proof of concept that a user could do it from the actual image itself by kind of clicking and creating the mask from that. So I just wanted to kind of mention that. I was just playing around with that just to see. So there's kind of two points there. One, that it would be kind of a user-defined mask from
sounds like a good
the
idea.
image. Cool.
Are you
Into
talking about
the
blocking out?
SVG.
Are you talking about blocking out things like neighbors' homes and things like that?
Yeah.
Also,
Yeah, that mask.
Mm-hmm.
okay. Yeah. Also, the tracks. The if you have tracks and bounding boxes, it would be cool if they would be transmitted separately as SVG, because then you could interact with them on the front side. So basically, if someone clicks on it, they would get the information that we have about it. Like if there's an ADSB correlation, you could have all that information by clicking on the track or the bounding box, right? So that would be a cool possibility if we have this going with an SVG front end side.
Mm-hmm.
Right? Because then you can integrate
That was
better.
kind of my again, without being knowledgeable about the current code base. That's the big caveat. Having effectively the coordinates of the border, however that's represented, whether it's an SVG, that's just one means of representing that. You can efficiently define a closed space. So that was kind of the idea. You could also get, potentially, there's other value in that, potentially being able to exclude that from being processed in other ways to gain efficiencies down the road. If those areas don't need to be processed visually, you might be able to free up computation.
I had started a mask, by the way, and I can send it to you, but it's not finished because it's still very basic.
So just for explanation, the idea that we had with the mask in the past was to mask away things that are in the view but shall not be monitored. For example, the sleeping room of the neighbor, for example, you block that away. Or a window that is reflecting street light, because it would cause the tracker to react on. You don't want to see that, so you mask this away. And the remaining part is the free view to the sky. That's the idea. The idea was to create an image, and the demo was done by Rebecca, and I think it's on GitHub also, the code, to create a bitmap with an alpha channel. Correct me if I'm wrong, I think we were still with the alpha channel, where if the alpha is 0, then it's masked, and if the alpha is 1, then it's visible. And this is a bitmap, and this bitmap is then stored in the camera. So the idea was, it was an old idea, but I think we have to change. We have to change from there. So the old idea is to create our own firmware, which Christian is working on, but we don't have it yet. But the idea was to create, to take that mask that is created by the user in the user interface, saved, and when it is saved, then it is moved on to the camera. So when the camera produces an image, that this mask is the first thing that is added onto the image by XOR, for example. So, and then you get with this pixel exchange is a very fast process that can be done by the firmware, by the process on the cam, and we get already masked material. And the question was always, do we need the original material without masking? And there was always discussion, and we can discuss it. My personal opinion is, if the user masks something because it needed to be masked, then it should not be in the original video. I think if the sleeping room of the neighbor is on record, no matter you masked it for the tracker, you still have it in the original video, I think that's a no-go.
But then this is awesome what Dan has created. I mean, he already showed me. Essentially, you can do the SVG masking roughly on like with your mouse.
Yeah.
And then we would possibly create a bitmap from that SVG,
Yeah.
and then that could be sent off to the camera.
Yeah. So for now, it's not that we have the firmware. It was the idea. Now the situation is that we have an image for the Orange Pi and a QHY driver that is used. Fabio, please correct me if I'm wrong. So we cannot upload this to the camera. Another process that picks up the stream from the camera has to do that first.
Richard,
Mike?
just a quick one. There is a mask image that is applied to the camera stream that comes in currently. Just so that you are aware, there is. So we do go through a process of applying a masking image. So that functionality is available, although not in the firmware. It is in the tracker application. So if these guys wanted to basically upload the image and make it available to that masking service, then it we can get it to work. So we can have that feature. And then when the firmware is available and ready, we can eventually move it into that.
Yeah, when it will be available. But for now, okay. I think it's you pick it up at the moment when the stream comes in, you apply the mask as first thing that you do.
Yes, agreed. Yes.
Yes, okay, perfect. So
yes,
basically you can check mark that. We just need the means in the user interface for the user to create that. That is just
I think we also need to
upload the kind of very, very kind of crude proof of concept that I threw together on the GUI channel, just to get an idea of, again, just a very basic implementation that we can make nicer.
I'll post mine. Dan, I'll post mine as well in the GUI channel as text files, and just save it as HTML and CSS file when you put it on your computer. And
awesome.
Maybe there's something there that you can use or not. And then
totally.
That I'm posting did actually work with Mike G with whatever he was doing at his end. I don't remember. It's been a while. But just to give you an idea, because I think he needed to receive his file as a JPEG, wasn't it, Mike?
As a JPEG.
With a white background and black.
Yeah, something like that. Yeah.
Yeah. We went through a whole bunch of hoops to get it to work.
Yeah.
Okay. Gotcha.
I think it's worth. I think Dan, it's definitely worth you sort of doing. Take your approach, and then maybe at some point we can have a look and see if, and then just pick the best approach, sort of thing. You know, I think there are many ways to approach something. So if it's a different approach, then it's definitely worth having a look.
But if we do have something
and
that is
pursuing.
working, it's good to know that too.
Well,
Again, you know, I being new to it, I you know, it's tough to know what
Of course.
has been done and what hasn't.
Of course,
But,
yeah, no, of course,
yeah.
yeah.
I want to say
Of course.
SVG might be better. SVG might be better because I noticed that when Mike G uploaded the camera mask that he received from me, because it was a JPEG file, there was some lossiness to it. So maybe SVG will be better.
Yes.
And I
Yes.
think
Yes,
might have
you're
been
right,
an
yeah.
issue as well.
Yeah. So I would maybe now give a live demonstration, if that's okay.
Yeah.
Yeah. Okay. So so first I'm gonna start the Rosbridge server, and I'll start Simple Tracker. I don't. There will be an error, but that's no problem. That's because I don't want the display from the X server shown, and that's okay. So assuming this doesn't suddenly not work. Yeah. Okay. Let's just briefly check. One moment. Okay. One moment. Yep. Okay. This works. Now I will start the server, the Node.js server with OpenMCT, and open it. Okay, and I will show the Rosbridge server on the Simple Tracker side. And where was I? Here. Okay, and now I will open the video stream. And here's the video stream. For me, this is rather okay. I don't know if on your side through the video this looks a bit more broken, but interrupted. But from my side, it looks pretty continuous as a flow or a flight.
No, it's continuous.
Okay, good. So that works.
So this is actually a stream, not a video stream, but an image stream.
Yeah, correct. But this is the same on our X window in the Simple Tracker.
Yeah. Absolutely. I just want to make sure that it is not a video stream, which would imply decompressing. And there's the mask as well. I see a mask on the right side, so it's already a masked material. Okay.
Yes.
Yeah, of course, it's run for simple. Sorry, stupid me.
Yeah.
Of course.
So now let's say I stop the server. Okay. Obviously, it will stop. If I relaunch it. Yeah.
Oh, it reconnects.
Yeah, because the issue it would only have if the Rosbridge server, if that's the connection that it has to actually uphold, right? If I stop the front end, that's no problem. If I stop the node, it's no problem. But obviously, if I stop the server, then I would have to reconnect to the server to WebSocket from the front end. Then this front end would have to reload. Yeah. So yeah.
Okay.
Because of the difference between the WebSocket communication versus the publisher subscribe system in ROS. But yeah. So I can now.
That's great, dude. I think that's.
Show you if let's say I stop the server, and just so you see it's really happening on the container. Now here's nothing. Now I start the server, and reload. So because this is not so essentially this the Rosbridge JS is completely on the front end. So this part, even if the server breaks down, it would continue to stream. I mean, I can just, I guess, show that. Yeah. So, yeah.
And the Node.js server is running on. So the idea is to run that on the Pi.
Yeah, right. But it's a separate container. It's a queer OpenMCT container, and the container has been built by Fabio both for AMD 64 and for ARM 64 already. So that Pi side should not be the issue.
And I think that based on we still have to kind of learn the, as the whole system comes together, what the requirements actually end up being with respect to the hardware that's needed to support the front end, whether it needs to be on.
Right, but in terms of having the container run efficiently on the Orange Pi, as it has been built for ARM 64 as well, that side, so we could right away try it out in principle.
Can you say anything about performance? How much performance does it consume on the Pi? My question is there enough power on the Pi left to do that job?
Yeah, that's obviously hard to estimate, but this side, my assumption is that this takes way less, like orders of magnitude less performance than any image processing kind of algorithm.
Okay.
So this is not, we don't do any real image processing beyond on the simple tracker side, the conversion to JPEG. So this is the main performance bottleneck would probably be the JPEG conversion, the compression to JPEG. But yeah, so but I think that so I can give you an answer, but I don't see a specific computationally demanding thing that we're doing.
Okay.
I think we're going to just have to try it as well.
Exactly.
Sort of thing, Richard, see how it goes, really.
Yeah. So maybe I could now stop it, and so Dan could show his. So to clarify, Dan, yours was a recorded video stream and not straight from the tracker, or was that?
You're talking about the dome video?
Yeah.
That is correct. It was a recorded video.
Yeah.
That I just projected onto a dome.
Yeah, well, I don't think that should be any problem because going straight for JPEGs being projected, I don't think that is in any way that is not possibly going to cause as much hurt. So I
right,
think
it should be equivalent. I would imagine.
Yeah.
And I can let me just get my screen ready here, and I'd be happy to share this. Okay.
I have a question about the mechanisms of identification to distinguish birds from UAVs and so on. If we have them, or if we need them, who will be responsible for that?
Excellent question.
Yes, basically we have two processes at the moment. First of all, we track objects that move. That's what you have seen. And then comes the classification. What is it that is moving? And we do it on two ways. One is a kinematic analysis, where we just look at the movement behavior and derive from there whether it's a thing that behaves like a plane, And the second one is an optical classification, where a neural network is trained on knowns from planes, drones, birds, and so forth. So we get in the view that you have seen, you get a green square and you get the text underneath that tells you this is a track number XYZ, bird, probability 50%, something like this.
Okay. We'll see, I think.
Okay,
Yeah.
can everybody see my screen?
Yes.
Okay, I'll reload this here. So this is just the video. So I'm just gonna take a spin around here. Look up, down. Oh, look, there's a plane. You can zoom in. I actually have it limited right here. I would typically be able to zoom in a little bit further, but the zooming distance is limited right now. But I can. But I can take that limitation off so that I would be able to zoom in farther. Yeah, that's a very easy thing to do. But you can see kind of down further at the toward the horizon how much that there goes some birds. How much clearer, let's say, like the telephone post and the phone lines are.
Yeah, the projection looks correct. Things are square and lines are lines.
Mm-hmm.
I think the spherical projection is quite enough. I don't see anything.
I think it's
any need for going
I think
into.
It's.
Go ahead.
Well, I think it should be a pretty easy. I mean, it should be a pretty easy thing to kind of map it perfectly, and it's a one-time thing to do. But this is
it
you
would
can
always
see.
depend. Sorry, it would always depend on the optic that you use. So the fisheye that we're using right now, the Mikey 3.5, has a certain projection which is off from the spheric. It's not a perfect sphere. It's like you take a football, a basketball, and you stand on it. So you squeeze a basketball. So it's a little bit flattened sphere. But actually, we derive parameters, let's say kinematically with a neural network. It shall find whether this behavior fits into a certain groove of behaviors and therefore is whatever. I don't see the user doing an analysis here. It's just a representation. So that's why the projection is only for the user, or do you see it different?
Can you hear me? My AirPods died for a second.
Can you hear me?
Reconnect there.
Okay.
Yeah, I can hear you again. My AirPods ran out of batteries.
Okay.
So I think there's a few things that we can do. I think if we can have we can just have different settings for different lenses if they are significant. So if you choose, you can choose one. Another thing that we could do, spherical could be the default, and if you have one of these lenses that we have a setting for, you could choose that. I think that I'm gonna attempt to do a kind of to manipulate it and see how easy that is, but I think it's going to be relatively, because it was so close to start, I think it'll be relatively easy to kind of tweak the equation of that, of that curve. Plus, all you have to do is kind of look at it at night and look at the stars to see how close you actually are, to kind of see how perfect you get it. So I'll play around with it a little just to see, see how, see what we're looking at, because there can be some really neat stuff that we do in terms of putting objects into this scene if it is actually pretty precise.
So this representation in a spherical projection like this is this is, please open discussion here. It's just my personal opinion, not a common opinion. My personal opinion is that this is just something for the end user to play with. I don't see anything that the user is doing here for doing, I don't know, analysis kind of. Because anything that is analyzed or computed is done by software anyways. And this is based on the two-dimensional video data that is coming in. And we can tweak all kind of calculations that needs an exact form of projection to use that algorithm, that projection algorithm in the codes for analyzing, I don't know, size or speed or whatever.
Yeah.
My personal opinion is that this view is a sweet view for the end user, for looking on historic data. So what was recorded yesterday, and with the mouse following something and getting the analysis projected as well on the same view. I think that's the catchy thing. But for me personally,
I think so, and possibly.
Yeah, go ahead.
And possibly to get information from the end user. So maybe, maybe masking or something like that would be easier to do in this, or something, or there may be maybe an annotation of something. If we're asking for an annotation of an object, would be easier to show that object in a view that's captured from, even a still frame captured from this view versus the object shown on the fisheye, for example. So if an object is close to the horizon on the fisheye in 2D, the resolution on that for a person looking at it is, difficult. But if you were to show that in this view, and then, that bird right here, and you wanted a user to like annotate it or something like that, you might take a crop of that view and do something. And so just to, get some ideas flowing. But I think you're completely correct. This is very much a user interface, like a user experience feature. But it potentially is that data acquisition from the user tool, possibly.
Yeah, I get it. Interaction with the user and what we can learn from there.
The other thing that I would say is that it's from a just general aesthetics. It might be a good way of, to visually show. It just might be a good way of visually showing what's going on. So from a just, gaining more community adoption, and from a kind of marketing and branding perspective, might be a good way of kind of capturing, people's imaginations.
Absolutely. Absolutely. I'm totally with you in saying that this representation is much more user-friendly, because the user can orientate himself or herself in the environment. Whereas a two-dimensional view of a fisheye view, you have to really think through the image to orientate yourself.
Yeah. And another thing that you could potentially do, even with testing, you could put in the secondary camera. And you could even show the where it is aimed, and the lag times in a view like that.
Oh, yeah.
So when you're actually doing your mechanical testing, this could be a tool for showing the
difference,
showing actually where it's pointed. Versus where it is, if you're just looking at an area of the sky, you might not know if it's actually to the right of the object or to the left of the object to adjust for something. But if you're seeing that, a bounding box that defines the, view of the secondary camera, you might be able to more easily adjust for, the positioning mechanically.
Oh yeah, also really cool. What you could do is if you have both streams, you have your both camera streams, and you're locked onto an object, then you could have this view center whatever the point where the other one is looking at the moment, and so you would better know where you are right now.
Or how far you're off.
Yeah, both. But for the end user, ideally, this is where it is.
Yeah. You could also, if a track is recognized, you could even click on it and center the view to it, so that the tracked object is always in center of the view.
Right.
That was another thing that I was kind of thinking about, again, not knowing how you're planning on doing this, but if an end user is actually monitoring something, and let's say there are multiple objects being that have been detected and are being tracked, and there's some obviously priority placed, and there's a choice made by the system to aim the secondary camera and focus in. There may be circumstances when the user is they see something and they want to actually reprioritize manually, because they see something and they want to refocus that camera. This could be a mechanism to override something and readjust.
And to have an additional recording button, so that when you start recording, it's recorded what is in the view, so that you are directing the view, so to say.
Yes.
Won't we have any problems with combination of different coordinate systems? Because as far as I know, IDSB, they have a spherical system like longitude and latitude as the information. And this view, is it a true spherical coordinate system, or we will have to make something like additional or subtracted things from these coordinates?
That's a great question. This is currently it's a 3D coordinate system. 3D Cartesian coordinates. I mean, you could represent it in kind of any way you want to, but it's the image currently. This one that you're looking at is the fisheye camera projected to a spherical dome, just because that was the easiest implementation, and it looked decent to start with. But ideally, it's probably something tweaked to match the lens of the to the optics of the actual camera.
Maybe to clarify, any such processing where you would, for example, fuse the information of the ADS-B with the tracks would not happen in this coordinate system, because it would happen before on a ROS node where there's the normal processing, and this would only represent it. So any such combinations would already have happened, would be thrown into this image the way they are on the 2D image, and then just this would end up being projected on this plane for better visual representation. So this wouldn't cause any issues on that end, because there's the separation of concerns where the actual processing happens on ROS nodes, and the front end is just the representational layer, let's say.
Yeah, and I was just going to say that I'll pretty soon, probably today, I'll have an example of some other objects within a scene, just to kind of show you that type of experience. And one other kind of just thing to note is that there'll be, you could kind of rotate the orientation of this scene and put it into give it latitude and longitude, and plot it on Google Earth or Google Maps, and integrate this scene actually into Google Earth or Google Maps and have that experience
there's a simpler way then.
together.
Then there's a simpler way. So there's AstroPy. It's a library to triangulate, to get stars, ephemerides, and so forth. You can, with simple calls of this library, you can get
auto-rotate
transformations from geo-coordinates to azimuth and elevation angles, and these are the two parameters that you use for painting on the fisheye view. In the neural network channel, I posted the code for Nicola.
I think I saw that. I saw that. I'll take a look at that, and we could auto rotate, and then I love that idea.
Not necessarily auto rotate. The auto rotation, you can put the north compass somewhere based on the real orientation and so forth. But I think that the question from Daria was pointed towards what is the global coordinate system we're working in. And yes, I have to tell you, it's the geo-coordinate system that we're working with, because we are then first of all, it's a network of sensor stations globally. So every station itself has a geo-coordinate, and anything else doesn't make any sense, I think. And all we have to do is if data comes in, to transform it so that it is put in the right place. For example, here to put in the right place on a view, either two-dimensional or in this case, spherical projected. Did this answer your question, Daria?
Okay, you said 2D system without high.
With height. No.
With
geo-coordinates with height.
Oh, okay.
We need the height because anything that flies has a height.
Yeah, sure. But so now I have some questions to the antenna system of the passive radar. But I think I will discuss later with someone else.
Okay. Yeah, but definitely anything that has to be represented has to be has to be transformed in order to see it in a user interface. So you're certainly familiar with this. I mean.
Okay, so now I also have some questions about this camera. Now we discussed about this ethical issues and all these laws about personal life and so on. And if we will prevent the customer from breaking the law, and if we will have our own made filters to try to find these windows and not to give the customer the information about their neighbors and so on. Or it's just up to him?
No, it's basically up to him. So it's not that we own the network. We provide the means to build the network. So if someone in Nicaragua, sorry Nicaraguans, no offense, builds a station and the neighbor is having his bedroom and he records it, we cannot prevent him from doing so. He could set up any other camera and do the same. So it's not a specialty of our stations to work for spying to other people. The station will always be, the algorithms will be tweaked towards recognizing moving objects in the sky and not what the neighbor is doing with his wife, you know.
Yeah, but that's a problem, though. If you're going to post this stuff online for the general public to have access to, yeah, that's going to be a problem. He's going to have to find a mask to fix that. What I'm saying is that you cannot stamp this with Sky 360 logo and then put it out there for general public consumption, knowing that that is actually happening, because there are states here in the United States that's a no-no. You cannot record. That's peeping Tom stuff, like Texas.
Well, then we shouldn't have the legal base in Texas, because there are different regulatory locations.
It's not just Texas. There's a lot of states here.
Yeah, then not in the USA. Yeah, then it hasn't been as long as it's not hosted in the USA. I mean, there's bigger issues in Europe actually with with the European privacy standards. They're actually stricter than the US. But to some degree, I mean, of course, we should, if there's someone says there's a problem, we should of course make sure that this is stopped, and we should do the right things, of course. But we should definitely look for the legal location of the hosting, so we minimize the legal risk. And then, of course, USA is not so great, and EU is also not so great. So I think this is a future problem once we want to host things. But yeah, we should take that into account. The legal location should be somewhere where we don't get sued like crazy.
Yeah, we can even override data in a sense that, for example, if we have a central host then, where data is coming in and there's a complaint about one particular host that is infringing privacy of his neighbor, then we can imply another mask that we create by hand on the data that is coming from the station, because we cannot control that. I'm not flying to Nicaragua and tell him, but the data that is coming in and stored on the central server will then be finally masked with a special mask. The only way we can do it. We cannot fly globally.
Well, I think we determined that anything that was going to be public consumption was going to require at least one set of eyes, if not two, to confirm before it goes public. So at that point, you can, do what you want at that point.
True.
Okay, thank you.
Even that, I mean, this is good. We should do that, but even that isn't certainty, because they may always move the station, and then it's just, yeah.
Hey Dan, I have one question. With this projection, would you be able to have, for example, if you take several layers of information, for example, you have one that is the bounding box of the track, maybe you have a path, maybe you have meteorologic information, maybe they have ADSP information, then we get additional classification information. Can you overlay all that and represent in this view? Yes?
Yeah. So exactly. So you're spot on. This would be this can be an extremely good way to turn on or off external APIs. So whether you want to visualize radar data and overlay it in a way that so one of the things that I want to that I'm interested in being able to see how accurate those plane tracks are with respect to getting a correctly oriented 3D projection, and then see how accurate a flight flight trajectory actually is. And then you can do the same thing with satellites. Yes. You can do the same thing with stars. Yes. If you can see where the lights are supposed to be.
Where's the star going? Did you hear that?
Right.
One star.
Yeah, where's the star going? Right? And so you can, and then you can get really good. You can kind of even, you can imagine how you could we could learn from the radar data, like the cloud cover radar data, and compare it against the actual clouds that we're seeing, and potentially create topological maps of the clouds so that we can get height, more specific height references to objects, especially actually because you have planes traveling into a cloud at a certain place. You could get a very precise height based on that plane if you knew which plane it was, and you can get the plane at that time, the height of that plane at that time. So you can get some really good reference data that you wouldn't necessarily be able to get if you if you didn't have those data kind of correlated data sources. And really for me to be able to have those ideas, being able to see things connected in this way allows me to think about it like that. So awesome point.
There's an interesting aspect in this. So for example, because we see in the fisheye, we see all the stars, and we know the ephemerides of the stars. We know what star is where. And then we can correlate with what we see and then adjust our projection, for example, so that it really represents what is seen. So that, let's say, Neptune is really a little circle around the real light of Neptune in the fisheye view. Then we're perfect. And then correlate with GPS data coming from ADS-B sensors. So for example, if plane flies over a certain area with a GPS sensor inside and transmits its local GPS information via ADS-B signal. We receive this signal because we have an RF antenna, ADS-B filtered. We can read this. So in the second when it is transmitted, we know where the plane is, and we can correlate this with the view. But the view is already correlated with the stars. So anything that changes here is a change in, and now you will laugh, is a change in space-time. For example, that's the thing that Eric Bart is facing on Skinwalker Ranch. That the change in the GPS coordinate is not just because you have a limited number of satellites or you have a reduced view or whatever. It is that multiple GPS sensors at the same time show weird behavior or differences in data based on the location where they are. So there must be, at least on Skinwalker Ranch. The question for me is that it's just a long story talking short, whether we can prove this globally. You know, by your idea correlating this with the GPS, because the GPS data we got from the plane is just the sensor in the plane.
Well, so the other, along that line of thought, you know, if it's hard, so with external data sources, with third-party data, you don't necessarily know how accurate it is. You don't know how accurate it is at any one time. You don't. So if something is very inconsistent, but sometimes is accurate, you know, you have some sources that are always accurate. You have some sources that are always not accurate. You know, so we can, in potentially that data could be very accurate in some regions and not accurate in other regions, and that's tremendous data when we know it's, you know, if we have an idea of the, you know, confidence that we can put in it. So if we have a secondary source to, you know, to confirm or just, you know, give us an idea of the confidence level that we can have in a third-party data set, that does a tremendous amount to allow us to kind of rely or to know how we can rely on that, you know, external data. So because then we can actually choose to use it in, you know, more, be confident about how we use it in our assessment of other things.
Yeah. All right. Any more contributions towards the user interface? If not, I'd say we switch to another topic. Fabio is not with us anymore, and I think it is due because he has a baby right now. He probably had to run. Actually, I wanted to ask all of you whether your experience with the Orange Pi 5 and the image that Fabio contributed, what your feedback is, how your experience with this image is. Anyone? Feedback now? No? Oh, you lazy people. Okay, for me, I got my experience with it was that is someone talking and I cannot hear him? Tommy?
Nope, I think
Okay.
no.
So my experience with the image is there are 3 ports on the Pi. There are 2 stacked on top of each other. The upper one is a USB 3 and the lower one is a USB 2. And Bojan thinks that both are connected directly to the processor, and only the USB-C, which is next to the HDMI port, is the one with a dedicated USB processor. Is this true, Bojan?
Not really. Not really. I'm not completely sure right now, but USB-C is USB-C is actually USB 3.1 standard.
Okay, and Fabio said that the USB-C port is the one that you should connect your camera to. But the cable that came along with the camera is a USB-A. So you have to either find a new cable or an adapter. I ordered the cable, another one. So, and yeah, Fabio said that the USB-C is delivering the 24 frames per second he got, and yeah, it's probably better supported by the operating system than the other ports. So just use the USB-C when you use your camera.
Yeah, but for Ozzy works fine.
Where did he put his camera on?
Yeah, Ozzy put camera.
On the upper or on the USB-C?
On upper.
Really?
Upper USB.
Okay.
Yes, it working. And he said it was working like 6 hours, 12 hours without any stuff.
Question, where's the difference? Is the difference in the hardware or, I mean, the image is the same. Okay, we have to find that out.
So this is kind of, you know, we don't know yet what's going on.
So what I wanted to ask all of you is, when you have your Pi and your camera, please download the image from Fabio and install it and test it either with the USB, the upper one, or the USB-C. And let's see where we end. We have to find out what's going on.
Yeah, a little confusing is both these USB connectors is marked blue.
Yeah.
Which is, you know, so this is like a confusing, but
yeah.
We have version 1.2, so, but you can you are able to download manual version 1.0. This is a little confusing, so we're going to figure out what's going on.
Yeah, Chinese and their translations. Okay, any one of you who wants to demo something? David, Yannick, Mike?
Not at the moment.
Not this week, no.
All right. Okay. David?
I've got a very quick thing I can show.
Okay.
It's nothing much. I've been quite busy this week, so I haven't had much time to progress what I've been working on much, but I'll very quickly show you something. So I just kind of played around with the optical flow and trying to get cloud motion. Basically, you can map the motion vectors into HSV, hue, saturation, value, color space, and it can just give you a different way of visualizing the motion of the clouds. So, can you see that? Okay, sorry, I should.
Yes.
Yeah. So I'm playing around with this at the moment. This idea came from a research paper I was looking at. But yeah, I'm just going to find another way to estimate cloud motion as well. So there's a cool paper that's came out this year, I think.
Phase correlation.
Optimizing cloud motion estimation on the edge with phase correlation. So the method I'm using here is optical flow, which gives us a motion vector at different points in the frame. We can use phase correlation. So you do an FFT on the frames, and FFT on the current frame and a previous frame, and then you can calculate motion based off that. I've already kind of scratched the surface with that. I've not really looked into it in any detail, but they've given an overview of their algorithm, so I might try and implement that. And I would imagine with it being done in kind of Fourier space, it'd be much quicker to compute. So that's just an idea anyway. Not much to demo, but
yeah, well. Thanks, David. Great work as always.
Yeah.
I love to see this data in real time. And what you did is this correlation represents the speed in color. Was that correct?
Yeah, that's right. Yeah, so the hue channel encodes the angle of motion, and then the value channel encodes the magnitude of the motion. So it gives you, having those two things in those two channels gives you a nice way of visualizing things. I don't know where it would be useful. You could maybe overlay it, or I'm just thinking it might be a nice little thing to integrate into the observer node ultimately, and give us a different way of viewing cloud data. And I'm still playing around with it. I'll report, but I'll keep reporting back if I make progress on it.
Okay, thanks, David. Great job as always. I want to throw in a question towards the cloud movement. So we had discussed it last week. Maybe we just talked a little bit about it. But the thing is, if something is stationary in the sky, for example, there's a balloon really sitting and not floating in the wind. You know, these types of balloons. So if it's just sitting there, the tracker won't pick it up because it does not change its coordinates in the cam view. But it will give a hint, it should give a hint via the background subtractor that there is something that is not going with the flow. You know what I mean?
Yeah, I guess if you've got cloud movement and a stationary object, then you should be able to pick up on that, I think. Is that what you mean, Richard? Yeah.
Yeah, so a normal background subtractor, Mike, you want to say something about background subtractor, I assume. But a background subtractor just takes the previous image and correlates with the current image and see where the change, and with some parameters change over time and so forth. But this is a different one.
Yeah, I'm not. Theoretically, I'm not sure if it'll pick it up, because if it's stationary, then it's not. It's just going to become part of the background, sort of thing.
True.
Another just. I was just going to say another thought could just be to have a some level of have a sense of history on that scene, that whole scene, and for each region of pixels have a average values, and as they are significantly different for any prolonged period of time, that could test specifically for a either a stationary object. Like if you could specifically test for stationary objects, or you could just be testing for anomalies in behavior through that. type of mechanism.
So the only one thing we cannot track is something that is not moving. That's not possible. With the background subtractor, it thinks that it belongs to the scenery. But if the scenery moves, then we do not have any method at the moment that would find a non-moving part in a moving scenery. So my idea, and that's what my question is, would this outcome, what David is doing, this estimation, this optical flow estimation, how is the background moving compared to something that is not moving? So the opposite of background subtracting, I don't know how to say that.
Yeah, you could create reference points, effectively reference nodes, and map those reference nodes as, you know, have them be stationary effectively, and reverse the motion, so that your motion is actually
okay. So you
so
compensate the motion of the
the
background
same.
and see that there's something that's moving.
Yeah, yeah, and you might be able to see some things moving much more, you know, so than everything else. You know, those are the things that are very stationary. And you could probably mask for the things that you know are stationary in a, you know, in a scene or in an image feed. That might be one way of doing it. You just, if you're able to kind of create some kind of, I mean, you could triangulate clouds potentially. And if they have a defined, if I think he mentioned he's working at edge definition in some way, but you could just do a denser. If you had edge definition, or you could triangulate a cloud, you could apply a denser vector field to that specific area and get get reference nodes, and then and do that check periodically. There's a number of ways you could test and see if you could test for a stationary object, and you could, in terms of creating a test video feed, that's toss it down up there.
Yeah, of course. Yeah. But David, would you be able to find areas in the optical flow that are non-moving? So consider, okay, you segmentize the whole view into I'd say 16 by 16, for example, optical flow vectors representing every vector representing its segment. Would this optical flow allow for finding something that is not moving? I mean, the opposite of optical flow, the non-flow. Is there a feature something like this?
Yeah, I don't know. I have to think about it a little bit more, but I guess if you're not looking for motion, you could look for other features. So you don't necessarily have to look for something that's moving.
Isn't that essentially the repetition across frames? So you get the same on the same area over several frames, so it's just essentially more or less equality within some range of a noise threshold.
And especially if it's significantly different from the averages across a larger range. So, if something's dark during the day, on a sunny day, in the, for a long period of time.
So you could have a color gradient combined with the repetition of same area, same as an equality within threshold, and a color gradient that is strong.
Those, you could do those specific, those specific logical tests would be something that would get you. You could definitely get close. Those heuristics, it could get you ways to test it, and then you could probably start with that, and and if you can do it that way, I'm sure we could find a model that could even do it better. But that's how I would kind of logically think about it. That's the first thing that would come to mind. Those kind of average values over time that you shouldn't shouldn't be there with respect to the past. That behavior that's anomalous, and specifically with respect to the movement of it.
Yeah, so basically this is something we need in the future. We need a solution for this in the future, because things move in the skies and don't move. And if we can only find things that move,
we can look for some type of algorithmic test to do that.
Yeah. Anyhow, was just an idea. Any other demos for today? Otherwise, I'd say we close it because it's already on the clock. All right. So, thank you very much for joining the development session. I stop recording now.